I heard Antonio say that if two squares have the same area, they'll have the same perimeter. So why would that, or why wouldn't that work? Let's look at one of our first models we're gonna make. So we're gonna be working with an area of 36 inches. And I'm gonna draw two squares that each have this. Okay, so as you can see, we have two squares that are both 36 inches. So they told us that the length in this one is 3 inches and the width is 12. And the next one is 6 inches and 6 inches. So we know that the area for both of these is 36, and that is because 12 times 3 is 36 and 6 times 6 is 36. So we know that the formula for area is length times width. So we'll write that at the top so we can keep up with it. Equals length times width. Okay, now what would our equation be to find the perimeter? That would be length plus length plus width plus width. Okay, so we normally would think that two squares with the same area might have the same perimeter, but in this example, I'm going to be showing you different. So we know that our perimeter formula is length plus width plus width. So if we know that this length is 3 and this length is 12, we can do 12 plus 12 plus 3 plus 3. So we know that 12 plus 12 is 24 and 3 plus 3 is 6. So 24 plus 6 would be 30. So we now know that the area, we'll write in area so we can keep track of it. The area for this square is 36 inches. And we now know the perimeter for this square, which is the way around it, is 30 inches. So now we look at our next square on the bottom. So if we use the same formula, we'll do 6 plus 6 plus 6 plus 6. 6 plus 6 is 12, and 6 plus 6 is 12, so 12 plus 12 equals 24. So we know the perimeter for this one is 24. So we can clearly see that these two squares have the same area, but they do have different perimeters. So your question might be, why is that so? Well, when thinking about this, what am I trying to say? What operation do we use when we are finding area? We said that right here for our formula for area is length times width. So we're using multiplication, and for perimeter, we're using addition and adding the outside when area is just within. So why might the perimeter be different? That is because the numbers outside are different. When we have smaller numbers to add all the way around, it'll be less. When we have bigger numbers like 12s, it'll be more. So we're going all the way around. And also you might ask, is there a relationship between how long the width might be and also how much the area is, if it's a greater number or a lower number? Well, when we look, this is a higher number, or 12 is a higher number than 6. So when 12 is more, we got a larger area, or larger number for our perimeter. So when we think about that, the longer one of our numbers are, whether it be length or width, the probability of our perimeter being higher is much greater. So the main difference, or the main reason that two shapes can have the same area but different perimeter, is that the length and the widths are different. Just because this one is 36 inches in area and this one's 36 inches in area doesn't mean that each side is going to be the same. As you can see, this one's 3 and this one's 6. This side is 12 and this one is 6. So although it can be the same area, it can be a different perimeter because the outsides can be different numbers. Just like if we erase this, We can also say that this is 36 inches, same area. We could say that one side is 9 and one side is 4. And we could say 6 and 6 again. So there's many ways to get an area of 36. As you can see here, we done 6 and 6, so 6 times 6 is 36. And up here, for 36 inches in area, the length is 4 and the width is 9. So although they can have the same area, the perimeter can vary because the sides may be different lengths.